Hello. I'm Scottish, so subtitles are available at the end. All right, so who am I? I'm basically in limbo at the moment between jobs, so I start my new job tomorrow. So I was going to do a Paddy Power Betfair presentation, but I'm not going to do one now. But I will talk about some of the things that we've done during that time. So who am I? Basically, I was a solution architect that did the i2 project, which won OpenStack Super User. I'm going to do a shameless book plug here. Yeah, so that's my book, DevOps for Networking. I wrote that in about 12 weeks and didn't get any sleep when I was doing it. And I'm joining Just Eat tomorrow, so quite exciting. So I can't get too drunk tonight. So what I want to talk about is everything is code. So one of the things that you really have to do when you're implementing this model is kind of have buy-in from all the different teams that you're working with. So if one team isn't really bought into this model, then you're going to struggle because that will slow down the process. So really some of the rules that you kind of need to establish is you want to not just control code, you want to control the infrastructure, you want to control the networking, the load balancing, basically every single configurable item that you've got in the stack that you're going to be using in any private or public cloud, you're going to want to control and put it into Git. The other things as well is you really want your development teams to be able to self-serve against this. So if you're going to create processes, you need to involve them in it. You need to get their buy-in, and you basically need to make onboarding as easy as possible. Some of the other things as well is I'm a big advocate of immutable deployments. So not just images in terms of deploying a new image each time. I really believe that networking should be immutable as well where possible, because everyone's had that scenario where they've had a massive big stateful firewall. Basically, ACL rails get created by maybe a network team with a ticketing system. You want to automate those processes. Okay, so going into it, one of the things that I really believe that you should be doing is creating continuous integration builds. You're all probably really familiar with this, so I won't labor the point. But anything that you do can be put in a continuous integration process, even if it's in terms of config getting checked into source control, that should be tagged in version so that you can roll it back. So you might have a scenario where you're not actually doing a code build. That doesn't mean, because there's not a compilation process, that it doesn't mean that you can tag that and version it using a CI system such as Jenkins or Travis. And then when you're taking it to the next level, you really want to put all your artifacts in an artifact repository. So I'm a big fan of Artifactory because the release cycle is pretty awesome. They've got Docker registry as well, and they release new features all the time. So you can use that for containers, you can use it for everything that you need in terms of artifacts. So you can do RPMs, you can do apt-get stuff as well. So one of the main things as well is if you're going to do immutable infrastructure, you really need to make sure that your base operating system and build are part of a continuous integration process and a process where you can put out new images on demand. So although some people will maybe take an image like an AMI from Amazon and use that, I'm a big advocate of actually creating your own. So you don't know what's actually going on there, so you really want to be in control of that process. I know we touched upon that with the Docker Hub stuff earlier on. Even if it's a container or it's a virtual machine, you want to know where that image came from, and your security team wants to know what's going on to that, so they could review maybe a chef recipe or Ansible playbook or role that's baking those images. So big advocate for Packer because it can do AMIs. We used it intensely for OpenStack, so we had CentOS 6, 7 images, and we even did Windows images that took about 10 years to run, so that was lovely. We put a grad on that when we did that. That was his first thing in his job, so he didn't know any better. It's great. So yeah, use and abuse grads when you can. Anyway, that kind of sounded a bit seedy, so Anyway, I digress. So public and private clouds with immutable infrastructure, what I advocated when we were doing this was we always had where we had ACLs that the network team would have to clean up manually afterwards that weren't being used anymore. That then got you into a position where you had a risk because no one wants to remove an ACL because it might be used for some other application or it might break production, cause an outage. No one wants to be the guy that basically removes that from production. So every time that we deployed, we actually did A/B deployments in terms of networking as well. So we would we would spin up a new network on OpenStack. So you could do this in AWS, Google Cloud, whatever. And then you booted your new virtual machines into that network. You then tagged the profile of application that you wanted to install on it using metadata, installed that, and then when you were doing the next deployment, you would spin up another subnet. So you alternated between A/B subnets as well. So whenever you tear down a subnet, it removes all the ACL policies associated with it. So you inherently get automated cleanup when that happens as well. So that was a good byproduct. So you keep very clean network config. You put that onto the development team so they don't have to wait on tickets. So they could self-serve using an approved model that we'd went through with the security team as well. So that was a big win because you don't want to have to wait on tickets, and that was one of the main inhibitors for our dev teams. And when you're doing east to west traffic for application connectivity, it's just that Cedar range, but you just give a more broad range that covers the A and the B subnet that you're deploying to. Okay, so as I mentioned before, metadata when you're in a cloud environment is very, very important. So there's a lot of use cases that you can use this for. So I'm a big advocate of Ansible. We use it heavily at Paddy Betfair. One of the guys who works here today kind of introduced me to Ansible, Steve Pereira. He's maybe in the audience. I think he works here at Sainsbury's. So one of the things was we tagged the profile of application that we wanted, and then we deployed a particular role onto that virtual machine. So that's one of the use cases that you can use it for. Dynamic inventory as well means that you've got service discovery on pretty much all of your cloud inventory. So for instance, security teams could target if they had a patch that they needed to get out there right away. That would be an exception to the rule because you always want it to be immutable and go through your whole deployment pipeline process. But in this scenario, you could actually target it that way as well using the dynamic inventory. And one of the things we did at Paddy Betfair was we used it for lifecycle management of deployments. So for instance, if you've got your first deployment that goes in, while those virtual machines were, the new network was put in, we booted the machines up. You would tag the progress of that deployment on those instances that you'd booted. So for instance, if there was a failure with the Ansible role installing the application, or it failed at any other point, they would only reach in progress. It was only when they were swapped in and serving live traffic, they would be tagged as a live state. So for instance, you've got your next deployment pipeline coming along. So one of the first things that deployment pipeline would do was clean up all the images that were in progress so that you're not blocking your deployment pipeline just for one failed deployment. So it would auto-heal and correct itself. One of the other things is when you're dealing with 24-hour uptime for applications, what you have to do is design them for failure. So whether you're in a private cloud and you're using hypervisors or different racks, you should always be splitting it and basically meaning that if there's a failure, it's a percentage of the application that goes down. So what we did is we actually deployed applications kind of 200% across 2 data centers. So you could actually run it if you had a full failure in that data center. But you also have it where if you have a percentage, like a hypervisor could go down because you have hardware failures. That means that you've got your development team that's been paged during the night. But what they do is they don't actually have it where they just look at it and go, oh, only 30% of the apps went down because you're splitting it across the infrastructure. I can wait till Monday morning, it's fine, I don't actually have to do anything, and then tell the NOC team that. And one of the pieces of advice I would really give when you're doing a project like this is to really automate your day one activities. It can be very easy to say, oh, we're only going to do it once. We're not going to do it again. And then you basically go, oh, we'll just manually do it because it's too much effort. Your day one activity, you'll always do it again. No matter if you're creating a test lab to do it, another data center, it will come back and bite you, and you'll always go, I wish that I could have automated that day one activity. One of the things as well, when you've got a set of, we use day one playbooks where we would build out like all the dependencies for the network, and then the self-service automation would allow us to consume those networks. One of the things with that though is you have to make sure that the Git repository that you're using to do those day one playbooks is the same as your BAU repository, because otherwise they'll just get out of sync. So that's one of the things I would advise. Make sure that you build it so that you can do a day one and you can do your build and run activities as well. So along the way, there's some useful tools that I've found like pretty amazing that I'm going to touch upon that it kind of helped with the Paddy Power Betfair project. So one of the ones that we had an OpenStack private cloud across 2 data centers, but we had a lot of core services that we had to run outside of OpenStack. So before you could install OpenStack, you needed core services such as NTP, LDAP, DNS. You needed your network kit as well to be deployed. We used New Edge Networks as well, so we had our software-defined networking solution that we needed to install. So before getting that, you get all the automation from the private cloud provider using OpenStack, but you needed something to get OpenStack there, day one. So one of the projects that you can use is Ironic Standalone, which is the bare metal as a service project for OpenStack. So you can download this. There's a set of Ansible rules that will allow you to install this. And it really allows you agnostically to provision infrastructure. Just think of it as like Cobbler, but if it was good. So yeah, sorry for any Cobbler fans in the room. Then you really have Redfish as well. So this is a vendor-agnostic API that allows you to programmatically control servers. So this has come out where you won't actually have to go directly to DRAC or ILO. You could go to the Redfish API and then do all the operations that you need. So if you've got a mixed environment, it's very helpful as well. One of the vendors that I've been really impressed with is Apstra. So you might not have heard of this company at the moment. So it was made by a guy called David Sheraton, who's set up VMware and Arista. So he's got quite a good track record. So this is his new startup. And basically, we had this problem where we actually put on a consultant. We got him in to work with this for maybe 6 months. And what we wanted to do was create a CI/CD process for our network switches. And the issues were when you needed to create, like, put a new switch port on or something like this, you needed to know the order on that particular device of when to add this. So one of the things that this tool does is, as a network architect, you will define a blueprint for your network. So day one, you go into the tool, you set up, you say, I want a leaf spine architecture with, for instance, these spine switches, with these uplinks, with these. You don't even need to go into VLANs. And then what it does is it will zero-touch provision each of the different switches in your network. So you could have a Cisco switch, you could have an Arista, a Cumulus, doesn't matter. If it's got a driver for that switch, what it does is when it zero-touch provisions it with this open source zero-touch provisioning server, it will push an agent to those devices. Then it pushes the intent that you want of that network to those devices, and it will set up the leaf spine architecture for your network. So you can hot switch in and switch out switches as well with that. So that's something that we tried to do with Ansible at Paddy Power Betfair. And this was just, we actually met these guys when we were over in Austin, Texas for barbecue. And they didn't have a product at the time, and they told us about this product, and we were like, okay, it sounds kind of too good to be true. You've got a vendor agnostic system. It's like, we want to see the product. But yeah, it does exist now. And this product will actually tell you if you've got cabling issues in your data center as well. So how many times have you actually set up servers and then not known what's gone wrong and had to go to the DC team? And this gives you the analytics and actually tells you that. So it's pretty cool. So one of the other things on a similar track was, traditionally I'd always used Citrix NetScalers or F5s, for instance. But when you're deploying applications, it's not really an application-centric view of load balancing. So really you're dealing with constructs such as VIPs, for instance. You're like, oh, I have these VIPs. And then they're associated with this application. What AVI does is it means that you set up an application. You're not even touching load balancing. You will then just say, I want this application to be load balanced in this particular way. You set your load balancing policy. And then using a cloud connector for, it could be AWS, Azure, OpenStack, it will basically deploy automatically using the REST API calls behind the scenes, your load balancer for you. And then it will tell you with its analytics engine, the throughput of that application. And what's quite nice, I don't know, you probably can't see that, but it basically tells you from the client request coming in, the throughput at each stage in that cycle. So you can actually see how many times has the developer said, I've got an application issue, and it's the network. This will tell you that the network is not the issue, and it's slow response time on the application. And you can see absolutely every call that comes in. So if you've got 404s or something coming in, it's got, I think it runs Elasticsearch behind the scenes with a time series database. So you can see each request that comes in and then see where it's coming from. And for instance, one of the use cases that we used this from, we had a guy who was basically DDoSing DNS. And normally that would be like someone goes around and tries to work out who is doing that. But what we could do is just go straight in, see the client IP, work out whose machine that was, go to the person, and then just tell them. So putting analytics in the network is just so helpful. And it's just the common use cases that you can get so much information out of the tool with this. Okay, so when we're talking about storage and we're talking about stateful applications, and you talk to people about immutable things, one of the things I've noticed is whenever you go to an interview for a DevOps position, they will ask you how to do database deployments, because they don't know how to do them, and they're hoping that you will answer that question. That's one of the things that I've noticed anyway. So basically, the way that we did it at Paddy Power Betfair was we had the challenge of doing immutable deployments for Informix databases. When that kind of was suggested, I felt a little bit sick, but I got over it. And the way that we did it was we used block storage attachments, so we used pure storage for that. So we kept the operating system completely immutable. And then we treated everything as an attachment. So that's how we've deployed all of our stateful applications. One of the good things with Pure Storage and Cinder was you could actually hot copy from clones. So that's something that you can't do with Amazon EBS, but you could use the same methodology to do this. So you just need to make sure that you've got your playbook of transferring state to the new applications that's coming in, and basically keeping the operating system completely immutable with the storage, just a dumb attachment. The other thing as well, if you want to use NFS for some applications, so stuff like anything that's a naughty file system, you can use EFS and then you can mount it and use it. So there's no one particular use case. You need to check out the performance of it as well. iNodes are a big consideration when it comes to your NFS and EFS deployments. By the same token, you can do the same thing on OpenStack as well. So they have the block storage project called Cinder that we used heavily. So all of our MySQL and Informix databases were deployed on it. We could deploy Oracle as well if they didn't kill us for licenses. But generally, same way as well. So even if you don't actually want to use all of OpenStack, there's also available the Cinder Standalone project. So if you've just got a bare metal server, you can actually use Cinder Standalone that will agnostically have an API that will allow you to mount, say if you've got NetApp, you've got a bit of Pure Storage, you've got any other storage vendor. If they've got a driver for it, you can use that agnostic API, which is quite helpful. We've seen the OpenStack projects basically break this down so that you can deploy standalone versions of each of their services, and they're really quite useful, as seen before with Ironic Standalone, and you could use Cinder Standalone for this. Manila as well is used for NFS, so you can install that and manage any NFS solution. One of the things we were looking at as well was CephFS, which is quite cool. That's used heavily at CERN. You should probably watch the video because I've got a good story about this little guy here. These are actually the mascots for OpenStack, so each project has a mascot. I kind of think that they maybe just gave some guy that they didn't want to do development work that job, but yeah, I digress. So one of the tools as well that we looked at recently was Concourse. So some of you might know it well. It's something I would really recommend because we had something like 10,000 different deployment pipelines, and we were using ThoughtWorks Go for this. And you have a centralized XML file, which means it's basically cruise control with a new GUI, right? So it doesn't scale very well at all. So we were looking at something that would scale to meet the needs. So Concourse is basically an open source solution. There isn't a paid version for it, which is quite nice. And what it does is it allows you to treat infrastructure as code. So you will have a fly command line tool, utility, which will allow you to upload to the web server the new pipeline as code. So it's a bit like using a Jenkins file or something, but it's a bit nice. It's more nicely laid out and stuff. And then they have the notion of resources. So a resource can be like a new artifact that will be used to trigger your new continuous delivery deployment. One of the things that we found is Concourse is completely containerized, meaning every stage in your deployment pipeline is a container. So it doesn't share state between the different stages. Normally, people are used to having like a common workspace if you're using Jenkins, which means that sharing state between that, some of your deployment scripts might be locked into that. So what we did was we used etcd, or you could use console to basically share key value information that just lasted for that deployment if you needed to pass a variable between it. So it wasn't that hard to do. But Pivotal use Concourse themselves with Cloud Foundry, and they've got quite a nice scaling article that talks about the scale at which they can run, so I would check that out. And then finally, one of the things that I really believe in is, as you've seen, is immutable infrastructure. So how does that really fit in with containers? You could deploy a network, you could deploy virtual machines and then deploy your containers on it, and then just basically recycle the containers all the time. But then that brings security considerations because they'll want to make sure that not everyone's using CoreOS, right? So is your base image, so they'll want that refreshed. So we had it where we had a cycle where every 30 days an application team would have to redeploy their application. So how does that fit in? So the model that we were really going towards was we had a 30-day refresh cycle on the infrastructure that you use for your minions in Kubernetes. And that would be recycled. So we were using kubespray for that. If you've not used kubespray, probably most of you have because it's really easy to use. I would check it out. I kind of like that more than locking into your as a service offerings from AWS and Google Cloud because Kubernetes is really your abstraction layer. So if you can run a Kubernetes cluster anywhere, you can basically deploy your workloads if you lock into that lifecycle. So we really did it where we segregated it, where you've got your infrastructure deployment, where infrastructure team looks after it, and then your development team can just deploy onto those minions whatever they want.